Hi students, now we are going to discuss how to find the magnetic field due to a circular conductor carrying current under different cases. Okay, now first I will consider a single circular loop carrying a current I ampere. So we can see that the current is in the anti-clockwise direction and the magnetic field at this point P will be along the axis of the circular coil. Now P is a point along the x-axis I have taken. So the distance of P from the center O is equal to small x. And the radius of this circular loop is a capital R. Now we have derived an expression for this magnetic field due to a circular loop, that is B equal to mu naught I into R square, mu naught I into R square divided by 2 into R square plus this x square whole power 3 by 2. So this is the general expression, is it not? The mu naught I into R square divided by 2 into R square plus x square, okay, whole to the power of 3 by 2. Okay, now this is for a single loop, this is for a single turn. Therefore, for n number of turns, okay, small n number of turns I will consider. The magnetic field B is equal to mu naught n I R square. So n times the magnetic field increases. So it is mu naught n I R square whole divided by 2 into R square plus x square whole to the power of 3 by 2. So this is the general expression you have to remember. The remaining are only special cases. Now if the point P is lying at the center of the circular loop, that is x is equal to 0. When the point P is taken to be at the center of the circle means you will see that radius is r and the distance x is equal to 0. So in this case now x is equal to 0. It's a special case only, no? So I am going to substitute here x is equal to 0. Therefore, what is B must be equal to mu naught I into R square divided by 2 into R square plus x square is 0, is it not? So R square whole power 3 by 2, R square whole power 3 by 2. So this is now equal to mu naught into I R square divided by 2 into, this is R square whole power 3 by 2 will become what? R cube. Now in the numerator there is R square term. So I will cancel this R square term with this power 3. Therefore, what is the magnetic field at the center of the circular loop having one turn? So this for one turn this is equal to mu naught I divided by 2R. This is for one turn, single turn. So for one turn only. Therefore for n turns, okay, for n number of turns, so what should be the expression for B equal to n times mu naught I by 2R. So this is equal to mu naught into n into I divided by 2R. This is for n number of turns. Now the third one is a semicircular loop. This is a semicircular loop. But the left side of the loop and the right side of the loop, the conductor is a straight conductor, is it not? A straight conductor. So what is the magnetic field at P? There is no magnetic field at P due to the straight portion on the left and the right because the point P lies along the axis of the conductor. Just now in the previous video we have studied that if the point P lies along the axial line, along the axis of the current carrying conductor, there will be no magnetic field due to the straight conductor. Therefore, there will be magnetic field at P only due to the semicircular conductor. For the full circular loop, we have found the magnetic field. See, mu naught I by 2R. Therefore, for at a point P due to a semicircular loop, the magnetic field B must be equal to half, 50% of this field. So half into mu naught I. So half into mu naught into I divided by 2R. So this is equal to mu naught into I divided by 4R. 4R. Okay. This is for a single loop because semicircle has only half of one loop only. So it is mu naught I by 4R. Now this is another special case. Okay. This is another special case. It is not a semicircle. It is not a semicircle. It is a part of a semicircle or a part of a full circle also. It is called an arc. Now the two end points of this arc subtend an angle theta at the center O of the circle. So in this case, the magnetic field B is equal to mu naught I divided by 2R. This is for a full circle, is it not? Mu naught I by 2R into this theta divided by total angle 360 degree, that is 2 pi. Theta divided by 2 pi. This is also a repeatedly asked numerical in the IIT and the NEET. Okay. You take for example, if it is a full circle, if it is a full circle means what should be theta equal to? If it is a full circle means theta must be equal to 2 pi radian, is it not? So if you substitute theta equal to 2 pi, this 2 pi will be cancelled. Therefore we get mu naught I by 2R for a full circle. Have you understood? Now be ready to solve the numerical problems based on these two, straight conductor and the circular loop. In addition to that, we have studied the force acting on a current carrying conductor placed in a magnetic field, the force between two current carrying conductors, then Ampere's circuit law, and the magnetic moment of a circulating electron, like that. Okay, be ready.